Hello guys, welcome to the first session for your CET 2023 super short revision series. So over here I'll be starting with the class 11 chapter physical world. As you can see, the weightage is 0.23, which means approximately 0.23 questions have come over the years, which means there have been years where they've not asked questions from this chapter at all. So it's a very low weighted chapter. You can just go through it because you don't want to miss if at all a question comes from it. So again, if you are watching this video without watching the orientation session that I have uploaded already, I would recommend you to check out the link in the description, which would take you to the orientation session so that you would know how to approach these kind of classes that I've been conducting. And yeah, I think it's time for me to proceed. So first of all, you have to know that physics is like a Greek word which means nature. It's a Greek word which means nature. And then if at all they ask you who was responsible for super forces, it is going to be Albert Einstein who was responsible for super forces. You have to just keep this in your mind. And the third point would be, in a nucleus, as we know, there are protons and then there are neutrons. So the important point over here is the force between a proton is equal to the force between a neutron and a proton, or vice versa, which is equal to the force between two neutrons. You have to know this. This is going to be helpful. There have been questions asked from this concept. I think it would sum this up. And then we will go to the fourth point, which would be strength of forces. So you have to know that strong nuclear force is the strongest force, after which there will be electromagnetic force, followed by weak nuclear force, followed by gravitational force, which means gravitational force is the weakest force and strong nuclear force is the strongest force. However, the point that you have to keep in your mind is this will be true only if the range is really short, which is approximately 10 to the power minus 15 meters, which means if they give it for a range beyond 10 to the power minus 15, then you have to make sure that you do not choose the option as strong nuclear force is greater than electromagnetic force. You'll have to do the other way around. So I'll just put it over here. I hope you'll be able to understand. Electromagnetic force is greater than strong nuclear force when it is, like, let's say 10 to the power minus 13 meters and so on. Basically, it should be greater than the range written in blue color. I'm assuming you were able to understand that part. So now I'll be moving ahead. You have to know a couple of conservation laws, what it means before you start with anything, and I'm pretty sure all of you know because this is a revision series, but I'm still covering this up. Conservation laws are like conservation of mass, conservation of energy, conservation of momentum, and so on, which you've already learned. And a hypothesis, I've written a definition. I'm pretty sure you already know what it is through de Broglie hypothesis and so on. So I've written a definition. You can just read it if you don't know it, just in case. It's pretty simple. And then the third point would be about unification. So questions haven't been asked from this, but you'll have to know that scientists basically look forward to unify all the laws, and there have been attempts made and also achievements. So there's a table in NCRT which I would recommend you to just go through. I wouldn't say all the questions would come from these tables, but I've just included all the tables, the important ones, so that you know that there might be chances where they ask questions. So you can just read it, if not memorize, so that you'll have a basic understanding of this is table number 1. So you can just go through all. You would know a couple of them if you have finished the syllabus before. If not, it's fine. So here's table number 2, and this would include a couple of scientists that discovered your contribution along with country of origin. You can just go through this too. I'm not saying it's necessary to remember everything in the table, but there are chances that they are fact-based questions, and you have to know how to tackle this. So this is going to be the third table. This would be of the least importance, but you can still go through it. Like I'm saying, you shouldn't really spend a lot of time on this chapter because it has a very low weightage in the first place. But it would be beneficial if you just go through this. You can just read, if not memorize. And then the fourth table over here has a similar scientific principle along with the technology. It's pretty interesting how we can see that an Indian scientist and Einstein had come up with technology and principles. So yeah, with this you can see that I finished the chapter. It's more or less just this much. If you go through this much, I think you'll be able to tackle the questions. Again, you can go through the orientation session and know what exactly you have to do once you watch the session. If you haven't yet or don't have the time, I'll write it down here. Basically, you'll have to make sure that you solve all the questions that have appeared in the past 10 years, previous year question papers. This would be like the minimum. I wouldn't say it would be completely useful. It would be useful, but you have to make sure that you solve from additional resources, like how I mentioned in the orientation session. You can just watch it if you have doubts on how to approach these sessions. But I'm assuming this was helpful. If it was, kindly share it to your classmates, juniors, and anyone who's writing either CET 2023 or KCET 2024. It doesn't matter, but I'm pretty sure it'll be helpful. Thank you, and stay tuned for the upcoming lectures.